Hello, this is going to be a quick lesson showing you how to predict solubility using a solubility table. So the solubility table that we have in our data booklet is set up in a way that we can look up compounds by finding both the cation and the anion. Now this table happens to be set up so that most of our columns are anions. So it's kind of backwards to the way that we name things. So if we're looking to see if something is soluble, such as sodium chloride, we find the anion, the chloride, first. So we have our chloride here. And then we want to figure out whether sodium fits into the top category or the bottom category. So in this particular case, most substances of chloride have high solubility. So solubility greater than or equal to 0.1 means it's very soluble. We would say it has high solubility. If we were writing that in a chemical equation, we would expect we end up writing it as aqueous because it has high solubility. If it ends up in the bottom category, we would say it has low solubility or is a solid in a reaction. So if we look at sodium chloride, it's not one of our exceptions in our chloride column, so we would say it has high solubility. In comparison, let's take a look now at calcium sulfide. So if we look at calcium sulfide, we find the sulfide column, which is right here, right? Sulfide, not sulfate, or sulfite with an ITE. IDE is S2 minus. And then we need to find calcium. So in the sulfide category, we've got group 1, group 2, and ammonium, and then everything else. So in our case, calcium falls into group 2. So again, we see that we're in this solubility greater than. So we would expect calcium sulfide to have high solubility. If we look at silver sulfate, this time we want the sulfate column. And then we're looking, does silver fall into the most category, or is silver one of our exceptions? So this time we see silver is one of our exceptions, so now between these two things, we're down here in the bottom part, and we come over to here and we see that's solubility less than 0.1 or slightly soluble. We would call that low solubility. So our answer for that one would be low. If we were putting silver sulfate into a reaction, we would be showing it as a solid. If we keep going on to our next example, we've got barium phosphate. So back to our table, we need to find phosphate. So there's our phosphate, and we need to identify if barium is in group 1, it's obviously not ammonium, or if it falls into this most category. So if it's not one of the things listed, it's going to be most, and barium is in group 2, not group 1, if we look on our periodic tables, so it falls in the most. So again, we see this one has low solubility. So this is useful not only for predicting individual substances, but when we're looking at reactions, we can look at combinations of solutions and decide, are they going to form a precipitation reaction? So our first example here, sodium chloride and silver nitrate. So if we want to know if this is going to form a precipitation reaction, we've got two ionic substances reacting. So remember, that's going to potentially be a double replacement reaction. So if it's a double replacement reaction, the sodium is going to combine with the nitrate, and the silver will combine with the chloride. So we have to look at those two combinations in our table. So sodium with nitrate, we find our nitrate column, and we see, oh, they are all soluble, so that one would not cause a precipitate because it would have high solubility. Whereas silver and chloride, well, we find chloride and we find silver, and it isn't one of our exceptions, not the most, so that one has low solubility. So we would expect that, yes, we end up with a reaction because the silver chloride will precipitate. Next up in our examples, we've got magnesium sulfide and potassium acetate. So same thing, we have to look at how those are going to recombine. So the magnesium could potentially combine with the acetate, and the potassium could potentially combine with the sulfide. So if we look at those possibilities, we can do them in either order, it doesn't matter. So if I go sulfide and magnesium, magnesium's group 2, so it's going to have high solubility. We would expect it to be aqueous. And if we look up acetate, remember that's this one here, and it's combining, I just did magnesium with sulfide, I should have done potassium with sulfide. It's group 1, not group 2, but it's still in the high soluble. The acetate one is my magnesium. So magnesium's not silver, not mercury, so it must be in our most category. So it also falls into the high soluble or aqueous category. So we would expect that one would not form a precipitation reaction because both products have high solubility. A couple more examples. If we have barium sulfide and chromium sulfate, again, look at those two other combos. So barium with sulfate now. Start fresh over here. We've got sulfate and we've got barium. Oh, it has low solubility. And if we look at chromium with sulfide, so we go sulfide. Chromium is one of our transition elements, so it's not group 1, not group 2. It's going to fall into this most category. So it's also going to have a low solubility. So this one would be a precipitation reaction, but we'd be getting 2 precipitates, which, if we were doing this in the lab, means they're kind of hard to separate because they're both coming out as solids. One last example like this. Iron to nitrate and lithium bromide. So if we look at that, again, come back over to our prediction chart here. So we want iron with bromide this time around. So I look in my bromide category and I'm looking for iron. And specifically, I want iron 2. So I have no iron, let alone iron 2 in my exception list. So it's going to be in the most category. Iron bromide would be highly soluble. Okay, our second possibility, lithium with nitrate. So we go to our nitrate column and we see they're all soluble. So again, they both have high solubility. We would not expect a reaction in that one. So sometimes we just want to predict if there's going to be a reaction. Sometimes we want to predict what the reaction is going to be. So if we have something like this, where we've got an actual chemical formula and we're being asked to predict whether we're going to get a reaction, well, again, before we can predict if there's a reaction, we have to decide those pairs. So we do sodium with nitrate. There's all our nitrates are soluble. And the copper 2 in this case, because I took 2 nitrates to balance our copper, with carbonate. So if we look at that one, the nitrates are all soluble, so it's not going to be that. Copper with carbonate is not one of our exceptions. It falls in our most category. So only slightly soluble, that's the one that's going to be written as a formula with a solid. So we're going to end up with copper carbonate. but it is a double replacement reaction, so we need to show our other product. And then we need to balance it. So because we have 2 nitrates and 2 sodium on the reactant side, we need that on the product side to get our balanced reaction. If we look at our next example, sodium sulfate with nickel nitrate. So our 2 possible reactants are going to be sodium nitrate and nickel sulfate. So sodium nitrate, all our nitrates are soluble, so it will be a possibility. The sulfate's a little more complicated, so we need to see, is nickel one of our exceptions? No nickel anywhere in that list, so it's our most, so it's also soluble. So we would say no reaction on this one, or NR. If we were writing those products, right, we would have to write them both as aqueous, which is, you wouldn't notice any difference if you have aqueous and aqueous before and after. Okay, next one we have ammonium hydroxide and lead 2 nitrate. So our possible products, ammonium nitrate, well, nitrate's still well soluble, so not going to be that one, and possibly lead hydroxide. So I go to my hydroxide list, and I only have a few that are soluble. Group 1, lead's not in group 1, it's a transition. It's not ammonium, strontium, barium, or tellurium, so it must fall into the most category, which is down in the bottom here. So we go across and we see it has low solubility. So the lead hydroxide will in fact form a precipitate. So we would write a products for this one. And those products would be the lead hydroxide and the ammonium nitrate. Don't forget to balance them. So we need 2 of the ammonium and the nitrate, well, specifically the nitrate, but then we need 2 over here to balance our ammonium. One more of these prediction examples with a formula. We have sodium chloride and cobalt nitrate. So sodium nitrate, one possibility, high solubility. Cobalt chloride, so we come over here in our chloride category. Copper, you might mistake as cobalt, but it's not, it's Cu, not Co. Silver's not cobalt, neither are any of our others, so it does fall into our most category. We have high solubility for both possible products. So this one, we would end up saying no reaction. So there's a quick lesson on how to use our solubility table when we are predicting precipitation reactions or just solubility in general. Thank you.